Bismillahirrahmanirrahim. Assalamu alaikum. My name is Maryam and I'm from the Department of BS Chemistry. My ID is 004 and this is the course of Principle of Chemistry 3. And this presentation is presented to Sir Hindar Qureshi. And the topic that was assigned to me was of balancing the redox reaction. So let me take a start from the table of content of my presentation of redox reaction. So for the very first thing is we have to know what is oxidation, what are reduction, and then I'm going to talk about the types of the redox reaction. Then we should know what is oxidation number, what are the rules for the oxidation number, and what are the examples. Then I'm going to talk about what are the methods through which we can solve the balancing chemical equation. The first method is oxidation method and the other one is ion electron method. So what is oxidation reduction method? Oxidation reaction is defined as it contains addition of oxygen, removal of hydrogen, and the loss of electron. So this is the sodium, elemental sodium, and this is converted into cation because it has loses its one electron. So oxidation occur here. As we know that oxidation number of the element in the free state has 0. So as it loses its one electron, so there is a +1 charge on the cation sodium. In reduction, it is defined as it is basically the gain of electron. It is opposite of the reduction, so there will be addition of oxygen and removal of oxygen. So what this is the chlorine and which gain one electron, so it will become anion. By gaining one electron, the charge will be at negative. So chlorine in elemental free state, it has 0 oxidation state or oxidation number. When its gain electron -1 will be the charge, means the oxidation number decreases, so the reduction will occur on the chlorine. What are redox reaction? Oxidation redox reaction are also known as redox reaction. It is a basically chemical reaction in which electrons are transferred between two reactants which are participating into the chemical reaction. The transfer of the electron can be identified by observing the change in the oxidation state of the reacting species. These reactions include the formation of all compound from its element, all combustion reaction, reaction that generate the electricity, the reaction that produce cellular energy. Now, these are the example of the redox reaction. This is the general reaction in which A and B are the reactant, and one reactant will show oxidation and the other reaction will show reduction. These both are in elemental state, and when it loses an electron, it stores the oxidation, and when it's gained the electron, it's your reduction. This is the example zinc and copper. Zinc act as a reducing agent because it's lost electron. Copper act as an oxidizing agent because it's gained electron. So copper is produced, zinc produce oxidized product because it has been oxidized by losing two electrons, and copper has been produced by gaining two electrons. So the example of redox reaction is hydrogen and fluorine. This is hydrogen fluoride, and oxidation occur at hydrogen because hydrogen loses two electrons and these two electrons are gained by the fluorine. Thus reduction occur at fluorine. So hydrogen act as a reducing agent because it is being oxidized, and fluorine act as a oxidizing agent because it is being reduced. So there are four types of redox reaction. The first one in decomposition reaction, combination reaction, displacement reaction, and disproportionation reaction. Oxidation number. So oxidation number is also known as oxidation state. It is defined as the charge the atom would have if the element of the electron were not shared but were transferred completely. For any compound, the oxidation number is equivalent to the ionic charge, but for the covalent compound, there are a set of rules. So what are these rules? These rules are for group 1, all compounds have +1, +2 for group 2, and for hydrogen, with all non-metals it have +1, and with non-metals it have +1, and with metals and boron it has -1, and fluorine with all the compounds has -1, oxygen in peroxide -1, and except F, hydrogen peroxide fluoride, it has -2. And for group 7 or 17, the oxidation number is -1. Exception occurs here. So for balancing the redox reaction, there are basically two methods, oxidation number method and the half reaction method. So I'm going to talk about the first method, which is the oxidation number method. We have to assign the oxidation number to all the elements in the reaction. First of all, The oxidation number is assigned. This in the second step, we have to tell that which species oxidized and which species reduced. Then we have to compute the number of electrons which are lost and gained in the chemical equation. Then we have to multiply it with the integers to equalize the loss and gain of the electron. Then we have to balance it by adding the matters. So these are the examples in which aluminium and sulfuric acid react with each other, and aluminium sulfate and hydrogen gas is liberated. This is lead sulfate which reacts with which is oxidized, and then lead oxide and sulfide gases, sulfur dioxide gas is liberated. So this is the first reaction, and we solve it oxidation reduction method, oxidation method. So the first step is to assign the oxidation number of all the elements. Aluminium is in free state, so it has 0. Hydrogen has +1 as it belongs to group 1. Sulfur has +6, oxygen has -2. When it's this is the compound, and the sum of all the oxidation will be equal to 0. We have to write oxidation state according to the rules. So the first is oxidation number assigning to the elements. So we have assigned oxidation number in the second step. We're gonna tell what is the species which has been oxidized and which has been reduced. So aluminium has been reduced. Aluminium has been oxidized here because the aluminium in free state, then it loses 3 electrons, and then from 0 to +3. So it has been oxidized. Sulfuric acid is being reduced because from +1 it has gained 0 electrons. So it has 0. We have to compute which electron is lost and how many electrons is gained. So 3 electron is lost by the aluminium and 1 electron is gained by the sulfuric acid. In the fourth step, we have to multiply with the factor or integers to equalize both electrons. So we have to multiply with the 3 so that we can equalize the both sides of the chemical reaction. Then we have to balance the chemical equation by fraction. So this is the second example. First of all, we have to assign the oxidation number. Then we have to tell which one is oxidized and reduced. Then here we have tell how many electron is lost and gained. Then we have to multiply with the factor so that we can equalize the gain and loss of the reactant. Then we have to compute the balancing chemical equation. So this is how we have balanced the chemical equation through first method. Now it's the turn of the second method. The second method is ion electron method or half reaction method. First thing is to write the skeleton and then cut it into 2 half reactions, oxidize reaction and reduction reaction. Then we have to balance the charges and atom. Then we have to multiply with an integers to equalize, and then we have to balance it. These are the 4 steps. So this is the flow sheet. This will become very easier because first thing is to write the skeleton, and then the second step is to write the chemical equation into 2 parts: reduction half reaction, oxidation half reaction. Then we have to balance it, and the balancing order will be like, first we have to balance the element except hydrogen and oxygen. Then we have to balance the oxygen. We will use proton and water molecules also. Then we have to balance the hydrogen. Then we use proton, and then we have to balance the charges. Means we have to balance the electron. Then there will be a balanced oxidation half reaction. There will be a balanced reduction reaction. Then we equalize the electron, and then add up the half reaction and cancel the identical species and check the element and the charge balance. So these are the 2 examples: chlorate ion and iodide ion. This is in acidic media and this is in basic media. Both differ with each other in the second method. So let's take a glimpse on the both method of these examples. So this is the equation of acidic, and we have to divide into 2 parts. This is chlorate ion. So oxidation occurs because we have seen that oxygen is lost in the reaction. This is reduction because electron is gained right over here. So in the second step, we have to balance the atom and the charges in each half reaction. Atom other than hydrogen and oxygen. So this is chlorate ion and this is chlorine. Chlorine is all over balanced. And in iodine is balanced by putting the 2 coefficient right over here. Then we have to balance the oxygen by adding the water into the 8. We have to add water on the right side of the oxidation half reaction method, and other reaction will be remain unchanged. The second preference, balancing of the hydrogen by adding proton. Here we have added proton to equalize the hydrogen adding. There it will remain unchanged. So oxidation half reaction, the last step is the addition of the electron and the removal of the electron. Transferred electron is added or removed, right, according to the oxidation and reduction method. Then we have to multiply it with the integers to equalize and to cancel the identical species. These are add up, and the electron having same 6 electron will be cancelled out, and then we have to check out either these all the chemical equation is balanced. Yeah, it's balanced now. So chloride ion act as an oxidizing agent because it gains electron, and iodide ion reacted and reducing agent because it's lost an electron. So this is the second example in the basic medium. These both are same because we have to divide both in the half reactions. Then we have to balance it according to the atoms, oxygen, hydrogen, and then by adding electron. We have to multiply each half reaction by the integers. Then we have to add. But the fourth step is differ in the basic medium because we have to add hydroxyl ions in this. And the fifth is to check. The only difference in the benzene chem redox reaction that takes place in the basic medium is the step 4 because we have to add the hydroxyl ions. So these are the for the practice. You should practice on these all the things. This is the copper is being oxidized and iodine is being reduced, and this is how we balanced it. This is also for the practice. Iodine is being oxidized by 1 electron and chromium is being reduced by 3 electrons. So what are the applications of the redox reaction? It is used in electrochemistry in the cells, nascent cells. These all are the application of the redox reaction. It is used in the combustion, in the photosynthesis. The reactant are carbon dioxide and water, which gives the product by reacting glucose, water, and oxygen as side product, and use oxygen as for the respiration. So in real life uses of the redox reactions include electrolysis. Many chemicals like caustic soda, chlorine, etc. are being produced through redox reaction. Oxidation reduction reaction also find their application in sanitizing the water and the bleaching material. The surface of many materials or metal can be protected from the corrosion by galvanizing the steel. Industrial production of the cleaning product involve oxidation process. Many fertilizers for the oxidation reaction of the ammonia, and for electroplating, metal are being separated, and for food spoilage, which is the main source of the oxygen. Thank you. That's all from my side.